So, reviewing quantitative chemistry. Remember, this means it's all to do with calculations.
Okay.
So if you're doing calculations, the very first thing that you need to start off with is a balanced chemical equation. Now, there are all sorts of calculations that we might be able to do with regards to mass or volume or pressure or anything like that. But the first thing you must start up with, if you're talking about something with reactions, is a balanced chemical equation.
Yep.
Now remember, your balanced chemical equation gives you the stoichiometric ratios. So you must make sure that this is correct.
Yep.
Now, once you've got the stoichiometric ratio, that means you have the ratio in which the reactants react and the products are produced. Okay. So once you have that, then it's quite simple. You understand the concept of the mole.
Yeah.
So a mole is basically a unit which equals 6.02 times 10 to the 23, which is also Avogadro's constant. And so just like a dozen is 12, a mole is 6.02 times 10 to the 23, to 3 significant figures. And the whole point of a mole is that if one atom weighs, let's say, 12.01 relative atomic mass, then when you say you've got 1 mole of, one carbon atom, right? When you've got 1 mole of carbon atoms, or in other words, 6.02 times 10 to the 23, you don't change anything, except you change the relative atomic mass, or AMU, into grams.
Yeah.
And that is it.
Okay.
That's the point of moles.
Yeah. Okay.
So with that in mind then, when you actually calculate, so the point is now from masses, we can now calculate the number of moles. And it's quite simple actually. The number of moles must equal the mass divided by the molar mass. And this is quite a simple concept, right?
Yeah.
How many boxes did you buy? Well, it's kind of like saying, well, depends on, if each box has, 10 pens and I've got 200 pens, then the number of boxes I bought is the number of pens divided by the number of boxes per pen. And that's the same thing here. This is the mass, this is the total mass, and this is called the molar mass. So it's the mass per mole.
Yeah.
So it's the same concept.
Okay.
If you have a certain mass, and you know that for every mole of that substance, it weighs a certain amount, then the ratio of those two just simply gives you the number of moles. Okay. And then we also can apply things to concentration. So remember, concentration is mostly a concept that is most useful for gases and solutions. And that's because concentration is defined as N over V. So concentration is the number of moles divided by volume.
Yeah.
So it's basically like, how densely packed, if you like, the particles are. And the reason why it's not really all that useful for solids or liquids is because solids and liquids have, volumes that are fixed, pretty much.
Okay.
And so the number of moles to the volume for that particular liquid or substance will basically be fixed, and so it won't change much. Whereas for a solution, the volume is dependent on the amount of solvent, how much water you add, for example. And for a gas, it's dependent on the container, which is why for gases and solutions, it's very, very important to calculate concentration because it can vary dramatically.
Okay.
And then you can, of course, rearrange this to get N equals CV.
Yep.
We also have your gas laws. And basically, you've got your combined gas law, which is PV must equal nRT. Key thing to focus on, of course, is that the T must be in Kelvin. That's very often neglected by many students, but everything else should be fairly self-explanatory. P is pressure, V is volume, N is the number of moles, and R is your ideal gas constant, which is 8.31.
Yeah.
And with that in mind, then, recognize that for gases at a particular temperature and pressure, their volumes will be proportional to the number of moles. So in a way, for a gas, the number of moles of a gas, you can also think of it as, the volume over molar volume.
Okay.
So that's a bit of a shortcut as well. So if you know that 1 mole of a gas is going to take up, for example, 24.79 liters under certain circumstances, and you've got, 100 liters, and to work out the number of moles, if you've already have the molar volume available, especially if it's at, a particular condition, like, 25 degrees Celsius, 100 kilopascals, or, alternatively at 0 degrees Celsius and 100 kilopascals, then you can quite simply just use the appropriate volume given in the reference sheet.
Okay.
And those are basically your calculations in stoichiometry. Now, you may also be asked to do things like, calculate yield, but I mean, as long as you understand what yield means, which is, how much you get, you may also be asked to calculate empirical formulas, or formulae, which basically means that you would simply take the ratio of the elements, divide by the masses of the elements to get the number of moles, and then work out the simplest sort of ratio between them. And then you go on to sort of molecular formulae by multiplying the empirical formula by some constant K.
Yeah.
But in a sense, in a nutshell, your stoichiometric chemistry basically relies on you knowing these formulas that we've listed here.
Okay.
And that puts us in a position to now go forward and review reactive chemistry.
Oh, also another question. So how is